Hello friends, this is Sandipan here. Welcome back to my YouTube channel. In the previous video, we started our journey with regular expressions in Python. We learned what regex is, how to use the RE module, special characters, quantifiers. We also explored essential functions such as search, find all, match, sub, split, and practiced with some real examples like word extraction and email validation. If you haven't watched part 1 yet, I highly recommend you to check that out first. The link is in the description below. Everything we will do today builds on those foundational concepts. Today, we are going to dive deep into some really powerful, advanced features of regex. We will explore groups and back references, learn about regex flags, and most importantly, we will build a practical password strength validator project that you can use in your real applications. So, without any further ado, let's get started. So let's start with one of the most powerful features of regex, groups and back references. Groups allow us to capture parts of a match. We create groups using parentheses. Let's see an example. In this text, to find the email address, we can create a regex with groups of expressions to match the three parts of the email like this. Here, we have created three groups of expression using parentheses. The first group \w plus captures the username part. The second group another \w plus captures the domain part. And the third group captures the extension. Now we can access each group separately using the group method with the group number like this. And as you can see, group 0 gives us the full match and group 1, 2, 3 gives us the individual captured parts. This is incredibly useful when you want to extract specific portions of matched text. Now here's where it gets really interesting. Back references, reusing captured groups. Let's convert a date format. Consider we have a text like this. Now to capture the date, we can create groups like this. So here we have used \d curly braces 2 to capture the first two digits, that's the day. Then a hyphen, again \d curly braces 2 to capture the next two digits, the month. And then hyphen \d curly braces 4 to capture the last four digits, that's the year. And then we will write the sub function with the date pattern that we have written and with the substitution pattern like this. And you can see it changes the date 25-12-2024 to 2024/12/25. Here in the sub function, we are passing the group numbers in a specific format. \3 refers to the third group which captured the year, that's 2024. \2 refers to the second group which captured the month, that's 12. And \1 refers to the first group, the day, that's 25. We are rearranging the captured pieces with slashes, year/month/day, instead of day-month-year. This technique is super powerful for data transformation tasks like converting date formats, recognizing phone numbers, or restructuring any patterned text. So let's take a breath and appreciate yourself because we are heading towards the end of this really complex yet super interesting topic. Let's continue and learn about regex flags. Regex flags modify how the pattern matching behaves. Let me show you with the most useful one. Till now, we have seen that the matching we perform is case sensitive. What if we want to ignore the case? The ignore case flag makes matching case insensitive. Let's see an example. Suppose we have a text. Then, using the find all function to search for the text awesome, we will pass the ignore case flag from the RE module as the last argument. And this matched uppercased awesome even though we searched for lowercased awesome. So the ignore case flag is really helpful when you don't want case sensitivity in your pattern matching. There are other useful flags too, like multiline for matching patterns across multiple lines, and dot all, which makes the dot match even new line characters. But ignore case is definitely the most commonly used one, especially for user input validation. Now let's put everything we have learned into practice with a real world project. Now here's a bonus project for you. Let's build a practical password validator that checks if a password is strong enough using regex. We will check for the following requirements in a password. It should be at least 8 characters long, contains at least one uppercase letter, contains at least one lowercase letter, contains at least one digit, and contains at least one special character. Let's create a function for this. Let me write the code first and then I'll explain it step by step. So here we have defined a function validate password which takes a password and returns a message based on some conditions. The first condition checks if the password length is less than 8 characters. If so, it will return the message password must be at least 8 characters long. In the next condition, we are checking whether the password contains any uppercase letters between A to Z or not using this regex expression. Also notice we are using the not operator to negate it so that if password doesn't meet this requirement, then only it will enter into the if block and return the failure message. The pattern square bracket caps A hyphen Z matches any single uppercase letter. Similarly, the next condition will check if the password contains any lowercase alphabets or not. Next, we are checking for any digits with identifier \d. Remember from part 1, \d matches any digit from 0 to 9. And lastly, we are checking for any special character in the password by mentioning a set of special characters like exclamation mark, @ hash, dollar, percentage, ampersand, asterisk, and so on. And finally, if none of the negative conditions are satisfied, it will return strong password. So let's test it with different passwords like this. Let's run this and see what happens. The first one fails as it's too short. The second one passes all the checks. It has uppercase letters, lowercase letters, a digit, a special character, and is longer than 8 characters. This is a strong password. The third one fails because it doesn't have any digits. Now you can see how Regex makes this validation so clean and efficient. Without Regex, we would need to write much more complex loops and conditions. This is a practical example of how Regex can be used in real applications for input validation. Here's a task for you. Try to extend this further by adding checks for consecutive repeated characters like AAA or 111, which makes passwords weaker. Try to solve it and share your solution in the comments. So that covers all about the basics of regular expressions in Python. In this video, we have learned groups and backreferences for capturing and reusing parts of a match, how to use backreferences to transform data like converting date formats, regex flags, especially ignore case for case insensitive matching, and we built a complete password validator project as a real world application. Regular expressions are incredibly powerful, and now you have the skills to use them in your own projects. Whether it's data validation, text processing, web scraping, log file analysis, or pattern matching. If you missed any of the points, make sure to rewatch it and it will definitely be clear. But if you still have any doubt, feel free to comment down below. Hope you find this video helpful. If so, give a thumbs up, share the video with your friends, and if you haven't subscribed yet, subscribe to my YouTube channel so that I can create more such helpful contents like this. Hope to see you in my next videos. Till then, goodbye.